Welcome to Techaily.ai, and welcome back to the Deep Dive.
Great to be here.
Today we're taking a really deep plunge into something foundational for modern IT, virtualization and hypervisors.
Yeah, these aren't things you click on every day necessarily.
Right, but they are absolutely the invisible force, kind of the unsung heroes making modern computing, and especially the cloud, actually work.
That's spot on. I mean, think about it. Streaming, cloud storage, collaborating online. It's all underpinned by layers of virtualization.
So our mission today is to unpack that, not just define it, but really explore how these technologies changed everything, why businesses can't live without them now, and what's coming next.
Because it's still evolving, right?
Absolutely. Evolution is fascinating, and it's definitely not slowing down.
Okay, and before we dive headfirst, a quick shout out to our sponsor, Stonefly. They're really crucial players in this whole ecosystem.
They really are.
Stonefly is a trusted solution provider and advisor in, well, pretty much everything we're touching on today. Enterprise storage, backup disaster recovery, hyper-converged infrastructure too, right? VMware, Hyper-V.
Exactly. Hyper-V, Proxmox clusters, even specialized AI servers, and also SA365, which is their turnkey security appliance, plus robust public and private cloud solutions.
So they cover the whole stack, basically, infrastructure and protection.
They do. You can check out everything they offer at stonefly.com. They're building the kind of infrastructure we're about to break down.
A perfect fit for this deep dive, definitely. They enable the tech we're discussing.
Okay, let's get into it. Virtualization. We throw the term around, but at its core, it's about abstraction, right? Taking physical stuff and making it virtual.
Precisely. It's technology that creates abstract, virtual versions of physical resources. Think of software essentially simulating hardware functionality.
And the big leap was getting away from needing a separate physical box for every single application.
Exactly. That was the old way. Virtualization lets you run multiple operating systems, multiple applications, all on a single physical machine.
Which sounds efficient.
It's a game changer for efficiency. Resource utilization goes way up, you get incredible flexibility, and costs go down. It's like having one super powerful oven, but you can bake, a dozen different things in it simultaneously, each needing its own setting.
Love that analogy. Okay, and that leads directly to cloud computing. It feels like you can't talk about one without the other. Is virtualization part of the cloud, or is it more fundamental?
Oh, it's absolutely fundamental. Cloud computing really is virtualization, just done on a massive shared scale.
Right.
It's the core technology that allows millions of users to virtually share the same physical resources, servers, storage, networks, all at the same time. Without it, the cloud's agility, scalability, that whole on-demand model, it just wouldn't work.
So the engine under the hood.
Yeah.
Got it. Now, you mentioned layers earlier. Virtualization isn't just one thing, is it? There are different flavors.
That's right. The core concept is abstraction, but it applies differently. Server virtualization is probably the one most people think of first.
One physical server acting like many virtual ones.
Yep.
Huge efficiency boost. Then you've got storage virtualization. This pools physical storage from lots of different devices into one single virtual storage unit. Makes managing it, archiving, backup, recovery so much simpler.
Makes sense. Pooling resources.
And network virtualization, which does something similar for network hardware switches, routers, firewalls. It combines them virtually to centralize administration, simplify management.
So you're abstracting servers, storage, networks.
And even applications, operating systems, data itself in some cases. The common thread is hiding the underlying physical complexity to make things easier to manage, more flexible, and ultimately more efficient.
It's really everywhere then. Okay, with all these virtual layers interacting, there must be something conducting the orchestra, right? Something managing it all.
Exactly, and that's the hypervisor.
The core enabler.
Precisely. The hypervisor is that crucial software layer, sometimes called a virtual machine monitor or VMM. Its main job is to manage the host machine's physical hardware. The CPU, the memory, the storage, the network connection.
All the physical bits?
Right. And then it intelligently carves up and allocates those resources to the various virtual machines or VMs running on top. It makes sure each VM gets what it needs, runs efficiently, securely, and importantly, stays isolated from the others.
Isolation seems key, like apartments in a building.
Good analogy. It keeps them separate and secure. It's the traffic cop and the building manager rolled into one.
Okay, and I know there are two main flavors of hypervisors. Let's start with type 1, the bare metal kind.
Correct. Type 1 hypervisors run directly on the physical hardware. There's no underlying operating system they sit on top of. They're the base layer.
And the advantage there is?
Performance, mainly. Because they have direct access to the hardware, there's very little overhead. You get better performance, typically enhanced security because the attack surface is smaller, and overall more robustness.
So these are the heavy lifters.
Definitely. These are the workhorses for big, demanding environments. Think large-scale enterprise clouds, massive data centers, web servers handling huge traffic loads. Anywhere, performance and stability are absolutely critical.
And who are the main players in the Type 1 space? We hear names like VMware.
Yeah, VMware vSphere, specifically its ESXi hypervisor, is a major one. It's known for really robust performance, especially with CPU and I/O, and it has a very comprehensive set of management features like vCenter. It's, mature, battle-tested, great for large enterprises.
Okay, what else?
Then there's KVM kernel-based virtual machine. This one's interesting because it's built into the Linux kernel.
Ah, so it's open source.
Exactly. That makes it very cost-effective and efficient. It's particularly strong in memory management and has become really popular in cloud-native setups, like those using OpenStack. KVM really helped democratize powerful virtualization.
And I've heard XN mentioned a lot, especially with big cloud providers.
Right. XN is another very mature, stable open-source hypervisor. It's got a strong security reputation and performs well, particularly using something called para-virtualization, where the guest OS knows it's virtualized and cooperates. AWS, Amazon Web Services, uses ES extensively.
Okay, and for Windows shops?
There's Microsoft Hyper-V. It's built directly into Windows Server, so the integration with the Microsoft ecosystem, Active Directory, System Center is obviously very tight. Makes it a natural choice for organizations heavily invested in Windows.
So, Type 1, bare metal, high performance, enterprise scale. What about Type 2 then? The hosted ones?
Type 2 hypervisors are different. They run on top of an existing host operating system, just like any other application you'd install.
Like running software on your Windows or Mac laptop?
Exactly. Think Oracle VirtualBox, VMware Workstation, or Parallels Desktop on a Mac. You install them like an app, and then you can create VMs inside them.
What's the main advantage there? Seems simpler.
Ease of use is the big one.
Right.
They're generally much easier to install and manage, especially for individuals, and they can be more cost-effective for smaller needs.
So where would you typically use a Type 2?
Perfect for things like desktop virtualization, maybe running a Linux VM on your Windows PC, or vice versa. Also really common for software development and testing environments, where you need to test an app on different operating systems without needing multiple physical machines. Or just for personal use, trying things out.
Right, like testing a new OS release or running some specific software.
Precisely. The trade-off, though, is performance. Because they have to go through the host operating system to get to the hardware, there's more overhead compared to Type 1.
So summarizing the difference, Type 1 talks directly to hardware, Type 2 goes through the host OS.
That's a key distinction, yes. It impacts resource allocation. Type 1 gets dedicated access, Type 2 negotiates. Management is simpler with Type 2, but Type 1 needs more admin skill. Performance is generally higher with Type 1, and isolation, that security boundary, is often stronger with Type 1 too.
Makes sense. Choose the right tool for the job, basically. But beyond just running OCs, the business benefits of virtualization seem massive. Let's dig into that.
Oh, absolutely transformative. One of the biggest impacts is just raw efficiency and cost saving.
How so?
Well, by dramatically improving hardware utilization, running many VMs on fewer physical servers, you cut down massively on hardware costs. Less servers means less power needed, less cooling needed.
Which is the energy bill.
Big time. And less physical hardware means less maintenance. Studies showed savings up to 40% within just 3 years in some cases. Plus, think about automation. Software tools can manage these VMs, deploy them, configure them much faster and more consistently than manual work. Reduces errors, too.
So fewer servers doing more work, cheaper to run, and easier to manage through automation. That's compelling.
Very. And it doesn't stop there.
What about agility? Businesses need to move fast these days.
Virtualization is huge for agility and flexibility. Because VMs are just software files, essentially, you can create them, delete them, or even move them between physical servers incredibly quickly.
Live migration, right.
Yeah.
Moving a running VM.
Exactly. Live migration allows moving a VM with no downtime. So imagine an e-commerce site getting hit with a huge sale. They can spin up extra virtual servers almost instantly to handle the load, then spin them down afterwards. That's dynamic scaling, rapid provisioning, workload mobility. It lets businesses react much faster to changing demands.
That responsiveness is crucial. And this flexibility must also play into disaster recovery. keeping things running if something breaks.
You're absolutely right. It dramatically enhances resilience and business continuity. Think about recovering from physical damage to a server that could take days with traditional hardware.
Rebuilding, reinstalling.
Yeah. With virtualized environments, you can often recover in minutes. Because the VM is just a set of files, you can restore it onto different hardware much faster. Features like those snapshots we mentioned, point-in-time copies, and cloning make backups and recovery incredibly fast and reliable. Live migration can cut data center downtime by potentially up to 90% in some scenarios.
Wow, 90%. That's a massive difference for business continuity.
It really is. It changes the game for keeping operations running.
Okay, huge benefits.
Yeah.
Cost, efficiency, agility, resilience.
Yeah.
But there's always a but, right? What about the security side? Does creating all these virtual layers introduce new risks?
Yes, it absolutely does. While virtualization provides that great isolation between VMs, it also creates new potential attack surfaces.
Where are the weak points?
Well, the hypervisor itself is a huge one. If an attacker compromises the hypervisor,
They could potentially access all the VMs running on it.
potentially, yes, it's a critical piece of infrastructure. Then you have the host OS in Type 2, the virtual networks connecting VMs, and the management software used to control everything. They all become potential targets.
So securing that foundation, the hypervisor, must be priority number one. How is that done? How do you harden it?
There are several advanced approaches. One is formal verification using mathematical methods to actually prove the hypervisor code behaves exactly as intended, catching flaws early.
Like a mathematical security audit.
Sort of, yeah. Another is designing with minimal components, basically, reducing the amount of code in the hypervisor to shrink the attack surface. Fewer lines of code, fewer potential bugs or vulnerabilities.
Keep it simple.
Right. We also use anomaly detection, often leveraging machine learning, to spot unusual behavior within the hypervisor or VMs that might indicate an attack is underway. And there are even things like embedded hypervisors, where the hypervisor runs inside special VMs for an extra layer of isolation, like with Kata containers.
Interesting. Okay, so that's the hypervisor itself. What about protecting the virtual networks and the VMs running on top?
Multi-layered approach there too. For virtual network security, you use things like VPNs for encryption, obviously, but also hypervisor integrated firewalls that can enforce rules between VMs. That's called microsegmentation.
Breaking the network into tiny, isolated zones.
Exactly. Stops attackers moving laterally if they compromise one VM. Plus, intrusion detection systems, IDS, specifically designed for virtual environments. And software-defined networking, SDN, helps automate setting up these complex security policies.
And for the individual VMs.
Standard hardening is still crucial patching, proper configuration, but also VM image scanning before deployment to check for known vulnerabilities. VM attestation uses hardware like Trusted Platform Modules, TPMs, to verify a VM hasn't been tampered with. VM introspection allows security tools to monitor a VM from the outside without needing an agent inside. There's even cutting-edge research into things like homomorphic encryption, which could allow processing data inside a VM while it remains encrypted.
Wow, processing encrypted data, that sounds complex.
It is, but it holds huge promise for privacy.
And in shared environments, like the cloud, managing who can access what must be critical. Identity and access management.
Absolutely crucial, especially in multi-tenant clouds. You need robust ways to authenticate and authorize not just human users, but also services and the VMs themselves talking to each other.
So things like single sign-on.
Right, using standards like SAML, OAuth, OpenID Connect for federated identity, plus really granular access controls who can do what to which resource. Some are even exploring blockchain for transparent, auditable authentication trails.
It sounds like security has evolved significantly alongside virtualization. But are there still big challenges?
Oh, definitely. There's always that tension between security and performance. Really stringent security measures can sometimes impact how fast things run.
The classic trade-off.
Exactly. Managing the sheer complexity of all these security layers and ensuring they work together across different platforms, that's another big one. Interoperability. And frankly, while some of these advanced techniques sound great, they need more real-world testing and validation before everyone adopts them widely. Security is a continuous battle.
It really is. Okay, so virtualization isn't static, it's constantly changing. Can we trace that evolution a bit? Where did it start and where are we now?
Well, the idea is surprisingly old. IBM was doing basic virtual machines on mainframes way back in the 1960s.
Wow, okay. Didn't realize it went back that far.
Yeah, but modern virtualization really kicked off, you could say, with VMware and its ESX hypervisor. That was maybe the first stage. Then came the second age, the rise of cloud platforms like AWS and Azure, built entirely on virtualization.
Bringing it to the masses.
Right. The third age saw the explosion of containers managed by orchestrators like Kubernetes, offering a lighter weight alternative for applications.
And now, are we in a new phase?
Many would say yes. We're entering what some call the fourth age, which is really about convergence
Convergence of what?
of virtual machines and those cloud-native platforms, especially Kubernetes. There are projects now, like KuGERT, that let you manage traditional KVM-based virtual machines as if they were Kubernetes pods.
So running VMs and containers side by side, managed by the same system.
Exactly. It blends the benefits. You get the strong isolation and OS flexibility of VMs, but managed with the powerful automation and orchestration tools of Kubernetes. It's bringing these two worlds together. That's a really significant shift for IT operations.
That does sound like a game changer, unifying management like that. What other features are emerging in this new era?
We're seeing much more sophisticated virtualization monitoring. Think AI-driven tools that don't just report problems, but help with automated analysis, troubleshooting, even predicting future capacity needs.
Making management smarter.
Definitely. Also, tighter integration into pipelines CI/CD, continuous integration, continuous delivery, automating the whole lifecycle of VMs and the apps inside them, reducing manual steps and errors.
And I keep hearing about GitOps.
Yeah, GitOps fits right in. It's using Git repositories, the same tools developers use for code, as the single source of truth for managing both applications and infrastructure. Highly automated, secure, makes collaboration and auditing much easier.
Infrastructure is code, but managed through Git workflows.
Precisely. And two other big trends shaping things are serverless and service mesh.
How do they relate?
Serverless architecture changes how you provision backend services. You essentially just provide the code, and the cloud provider handles all the underlying infrastructure, scaling, patching, everything. You only pay for exactly what you use. It leverages virtualization heavily under the covers, but abstracts it away even further.
Ultimate abstraction, almost.
In a way, yes. And Service Mesh addresses the complexity of modern microservices applications, where you have lots of small services talking to each other. A service mesh uses lightweight proxies, often called sidecars, alongside each service to manage that communication.
And what does that management involve?
Things like sophisticated traffic routing, security handling, encryption, authentication, authorization between services, and providing detailed observability into how services are interacting. It takes the networking burden off the individual developers and centralizes it.
So, looking ahead, more convergence, more automation, more intelligence.
Absolutely. Expect hybrid and multi-cloud to become even more standard, seamlessly blending on-prem and different public clouds. Containers will continue to grow alongside hypervisors, sometimes replacing them for specific workloads, sometimes running inside VMs. Security will keep advancing, hopefully with more hardware-level isolation built into CPUs.
And AI's role.
AI and machine learning will get baked deeper into the hypervisors and management layers themselves, optimizing resource allocation in real time, predicting workload spikes, maybe even self-healing issues. The hypervisor gets smarter. The whole digital world keeps expanding, so virtualization infrastructure has to keep evolving. Maybe we'll even see a fifth age soon.
It's incredible how fundamental this all is. So, wrapping up this deep dive, the big takeaway really is that virtualization isn't just some IT buzzword. It is truly the indispensable core, the absolute engine of modern cloud computing.
Couldn't agree more. It enables the flexibility, the scale, the security, everything we rely on in IT today. It underpins our digital lives, really.
It really does. So here's a final thought for you, the listener, to chew on. As this evolution continues, with AI, with containers, with maybe even quantum computing down the line, how will it reshape our very idea of what a server or a machine even is? When the virtual becomes even more seamless, more intelligent, perhaps almost invisible, what new possibilities open up?
It's a profound shift, moving further and further away from the physical constraints. Exciting times ahead.
Definitely. And before we let you go ponder that future, one last reminder about our sponsor, Stonefly. They are actively building solutions for this evolving world. If you need robust, secure infrastructure that embraces these trends, check them out. Specifically relevant to our discussion on storage and security, they offer a 100 TB immutable and air-gapped SSO NAS for just $8,995.
That's a serious piece of kit, focusing on that immutability and air-gap security, which is so critical today.
Absolutely. It speaks directly to ensuring data integrity and resilience in these complex environments we've been discussing. Find out more at stonefly.com.
We really encourage you to keep exploring these topics. Understand how this hidden layer of technology impacts everything you do online.
Thanks for diving deep with us today. We'll catch you on the next one.